Thank you very much. Okay. I'm Leonardo. I work as a red team leader with a team. I also do pen testing. Also, I'm a training of hacking techniques, security researchers, always on offensive security, because it's funnier than the defensive security. And I'm natural from Spain and Equatorial Guinea, mixed. So I'm very proud of my countries. Why I'm talking about infecting files? Because still nowadays you can find websites with popular software that lets you to download via HTTP without any encryption. For example, VLC or Videoland, whenever you want to call, is a very popular video player. You can still download it using HTTP. For example, if you go to the main web page and you hit download, there are several mirrors. Some mirrors are HTTPS, and another mirrors, for example, that one from Spain, is still HTTP. You have also one mirror of their own domain called downloadvideoland.org. Is also HTTP. So also, if anyone wants to download this program from the original source, he will do using HTTP. Other platform, for example, to download Windows executable is NVIDIA. If you download some drivers, you are going to download it using HTTP, unencrypted. This is how it must be, HTTPS, encrypted. Okay, everyone is okay with that. But the problem, for example, with Ultra VNC, also a popular program, is that the download page have this. Is a reference, when you click download, is a reference to an HTTPS URL on an HTTP. So every hacker, security professional will know that a simple SSL strip attack can't translate that to HTTP. So you are fucked with that. The policy is not well implemented. Also, when I talk about download files, or when other people talk about download files, they always talk about PE files. I mean, execute files, exe files. But we not only download exe files, we also download zip files, for example, DMG for macOS, document files of Office, PDFs. And as a security professional, probably we take care of where we get the exe files. But our defenses are low when we download, for example, a zip file. We don't think that a zip file can be infected, or a docx file could be infected. So, exactly what I'm going to talk about, Gamma can explain it. You know that, probably you know that Gamma Group is a European company that makes surveillance software, have been hacked some years ago, 4 years ago, I think. And there was a leak, and they published the software and the internal promotional videos. For example, this one is where they have a tool called FinFly that do a man-in-the-middle attack, and when an attacker downloads something, for example, in a hotel, they implement an attack to infect the file they download. This is the reason that I started to research about this, how it can be done by me, not with commercial software. So, commercial tools, first, as I said, the Gamma Group software. FinFisher is the pack of the tools. FinFlyLAN is the tool to do on-the-fly infections. Also, hacking team have been hacked 3 years ago after Gamma. And the hacker published the tools, a lot of gigas of information. And with that information, you can find the network injector. It is an ISO, is a Linux system that also do that. They had a tool to infect on-the-fly files. They are commercial tools. But also exists some free tools. For example, P-Injector. P-Injector is a lightweight software planned to run on a Raspberry Pi, for example. And it allows you to infect PE files, executables, Windows executables files. Okay, you have to do the man in the middle, etc. The problem of this tool is not maintain it anymore. I think that on GitHub, the last upload, the last modification is about 3 years ago. It's the same with BDF or Backdoor Factory proxy. It's not maintaining anymore. The last modification is, the last push is from 2 years ago, I think. It infects not only executable files, also from Windows, also from Linux and Mac O. It also infects, I didn't write it, zip files. But, as I said, no maintaining anymore. There are more tools, but are not really important, because also are too old, or they have several issues. Normal issues I found in general with that tools. First, the resource of the executables of the icons. Some tools, what they do is to change the executable by another. So, the target, if download a file, they change the executable, they are not going to find the right icon. So, the target will detect the infection or will be suspicious about that. And in an attack, in a real attack, in a red team or wherever, you don't want, the attacker don't want to be detected. Antivirus also, and we are going to see that later, the methods of infection normally are detected by antiviruses. The signatures of the executables. Sometimes I saw that the original code, the original program is not executed. So, if you change the file or you infect a file, the target hit it, click on it, and the malware is executed, but the original purpose of that executable is not done, you are going to be detected, of course. Also, doing this research, I found that several files do auto-integrity checks. I mean, for example, VideoLAN in Windows, if you modify the file itself, when you run it, the VLC will detect that has been modified and we launch an alert. Other problems as USC, as I said, all the files that we download are not executables, not all. Also, there is one thing. What do you think that on the fly means? When I talking about infect on the fly, what is that? Think that we are doing a man in the middle, and as usual, we are diverting the communication to a proxy, through a proxy. So, on the fly, what means? What a proxy do normally when you download a file? Okay, for example, okay. When we download a file, this is what happens. You see the bar, the progress, etc., etc. Now think that you are on a man in the middle, and now you have a proxy server. Here I'm using Burp, for example. The target clicks and is waiting. Nothing happens. Target is saying, what the fuck? Where is the file? There is no file. There is an error. But the router is thinking. That is, and suddenly it disappears, and fast we have the file. So, what's the problem there? The problem is that if the file is big, and we are downloading 51 megabytes, the proxy first download the file, and then it send it to the target. So that's the light time. It's really bad because, for example, in this case, the target can say, "Oh, it's not working," and click again and detect the error. So that is not real on the fly. To download the file, infect it, and send it, that's not real on the fly. So that's what this is what I explain. The client requests the file, the proxy downloads the file, then there is a file modification if you infect it, and then send to the victim. That's you can calculate more or less the total time, and it depends the connection speed. So if you are on a broadband, the file is not too big, okay, we can accept this. But it is too big, or your connection is not very fast. If you are, if the attacker is doing, for example, a root IP attack, that time can be that wait time can be detected. What I purpose? This is the way an attacker have to do that. The client requests a file. The proxy starts to download the data stream of that file. The proxy must modify the data stream to infect the file and send each data stream in the same way to the victim. So now you still have a dependency of the connection speed, but the target, the client, will see the file downloading. So it can say, oh, it's go slow if you are using a slow connection, a 3G, for example, or you are downloading a really big file, but the client will see the process working. the download working. Finally, the total time will be the same of the proxy downloads the time, file modification, and then send it. The total time will be the same, but the client will not see any awful process there. Now, we have to know how to modify that data stream before having the complete file. So we are going to see that we now depend on the file format. So, some facts. If we know the file format and we know how we are going to infect it, modify it, we can guess the future modification of the file. At the beginning, normally, using HTTP, I'm talking about HTTP, we know the original size of the original file. That size is on HTTP header content length. On the content length, we are going to see the complete the size. Which are going to be the file size? Which are going to be the content length? So how the file will grow? Sometimes we can know that, and sometimes not. It depends on the file format we are going to see before. Also questions is that file have a CRC. We are going to modify that CRC. We can calculate that CRC. Where are the headers? Which are going to be the headers of the modified file? So we have to study file format per file format. And I used the investigation, the research of Ange Albertini. He's a security researcher that describe many file formats. So I use his research for that. Okay, first I'm going to talk about P infection. Okay, this is the graphic that Ange Albertini did about the format of P. Okay, this is the same. In a P, there is a lot of documentation. You have several sections. I have a book there. You have several sections which we really care about that, is how to add sections to a PE format, and the resource section. The resource section is important because on the modified file, I want to put the same icon. So initially I started to research how I can extract an icon and then put it on the modified file. Finally, I saw that the structure is really complicated and is not well documented. So I decided to follow a different way, and you are going to see that. Okay, this is what I'm going to demonstrate is the executable infection. As I said, the original exe file must be executed. The process must be transparent for the user, to the target. And I have to take care of the file name, because the protections of the files, one is the file name, because the reputation, the Windows take care about that. The digital signature as another protection, and the integrity check, as I said. Option 1, to infect the files. This is one of the oldest way to infect a executable, is to add the malware code at the end of the file, change the entry point on the header of the file, remove the digital signature, the final file will not be signed. The new code have to be executed and then called to the original code. This is the way. The problem with this technique is that, okay, first, you can, after that, if you have a certificate, to sign that file. But the auto-integrity check that some files have will fail. This is a well-known method by antiviruses. We take care of the new size. We can predict it because it's the original file plus the new code. It's easy to calculate. And with this method, you preserve the icon. There is another method, is to add the original file to a malware, not the malware to the original files. I mean, the original file inside the malware in a section, then the malware execute its magic, and then copy that section to an external file and then execute. I mean, this is the idea. You have the original file and you put that file inside the malware, and then to the malware you add a copy of the resource section. With that, you have, the malware will have the icons of the original one, and he can copy that blob section outside to an external file and execute that. Again, the executable can be signed a posteriori if you have a valid certificate. As you copy the resource section, you are going to have the icon. The size, you can predict the size, is the original one plus the malware plus the original resource section. And some alignment you have to put. Here now we don't have the problem of the auto integrity check, because now what we do is to copy the original file outside and run it. So the original file is not modified. So the auto integrity check is not a problem anymore. Okay, I'm going to do a demo. Okay, I code a proof of concept, a tool called EDM. What this tool is a proxy. When a browser downloads an exe file, it checks the exe file, adds to the malware a new data section, change the size of the sections, then start to send the new executable to the client. So the client, since it click on the file, he will see that something is downloading. So sends first the malware, then sends the original executable, then sends the resource section to have the icon. How the proxy detects that the target is downloading an exe file? Using the content type header, it check if is that content type header. Application octet stream is a general content type for binary data, but it checks if is application octet stream and also the extension of the file is .x, so it start to infect it. Okay, let me. Okay, it's on other screen. Okay. Okay, this is the proxy. Here, this is the configuration for infecting executables. What we are going to do is to create a new malware that will join two executables. For one side, on the calc, for example, and the one that the target will download. After that, there is a launcher. A launcher is the one that is going to copy the box sections and copy it outside and then run it. What I did, what this launcher do is to copy, as I said, the two executables outside. I put these file names. Okay, I'm just going to execute it. Okay, modify X, and this is for the next. I launch the proxy. So at the start, it creates the malware and it's waiting. And now here's a Windows. Let's go directly. Download. For example, Yolan, VLC. Let's go to the last one. Windows. Okay. First, without proxy, save file. As I said, we had a good speed. Good. This is a normal download, what everyone see. And we want that with the infection to see the same. Okay. Perfect. Okay. We have here the VLC with the icon, USD VLC, etc. Now we simulate a man in the middle. Someone is redirecting the connection through a proxy, and we again download the same file. Something happened because it was the cache. Okay. Let's catch it. Without catch. Okay. Okay. We see here starting to work. Save file, and as we see the same process. Okay. Now we see that the size is a little bit bigger. The speed is the same, so there is no problems. Okay. What the proxy did is analyzing the first bytes of the executable. It predicted the modifications on the file and changed it on the header. Okay. It calculates the resources, etc., etc. Now we have here. Let me see. Okay. Okay, this is the original one. This is the second one. If we click here, they ask me the ESC, check that the origin of the file, the editor of the file is unknown because we didn't sign it. But if we execute it, we have the calc, okay, and the installer. We have both. Okay, and it was transparent for the target. Okay. Let's go back. Okay, this is the demonstration for exe file. Now I'm going to talk about zip files. The zip files is a format made by Pekyware. The format is basically, let's see there. Okay, each file is compressed individually and put it together on the zip. So the first file will have a local file header, the compressed file data, and a data descriptor. Then is the second file, the same, a header, a file data, and a data description. Then and the end files. Then some headers and record if the zip file is encrypted. And finally, a central directory with CRCs and an index of all the files. Okay. On the local file header is the first thing you see there. You are going to find a signature. Okay, the version of zip, some flags, what kind of compression have, the modification time, the modification date, etc. CRC 32 of the header. No, sorry, of the file, and the compressed size of the file data, and the uncompressed size of the file data, then the file name. After this header, we find the compressed data, and after that, the data description. Again, it's redundant information, the CRC32, the compressed site, and the uncompressed site. After all files, we are going to find the central directory where there is a file header, an index to all file headers, with again the same information. So it's not very complicated, and at the end, this is for multi files, etc., etc. Here, to infect zip files, we are going to take advantage of that. The first thing you see is the file name and the size of the file. So when you start to download the data stream of a zip file, you can see first if the name of the file you are going to download. So to infect that, the client starts to download a zip file. The proxy downloads the data stream, see, as I said, the local file header, and check, do I want to infect this file? Is it, for example, a GPG file? It don't want. If it is a DLL, it's probably, it depends how you configure that. It's a BMP, you don't want to infect. If you don't want to infect that file, you send the file to the client. It's on the fly, remember. If we want to infect that file, First, we need to download the whole file to uncompress it. We can infect the compressed in file. So we get the uncompressed data, we decompress that data, so we get the file, we infect the file with an external program, then we compress that file again, and we push that on the data stream. What happened here? You need to wait until you have the compressed file. So, and we want to have the line of the download working. For that, I use two tricks. The first one is you can put on the tool to infect a parameter. You can write a parameter that if the compressed file is bigger than a value, don't infect that. Okay? For example, if the file is bigger than 100 megabytes and you are in a slow connection, don't infect that, because I prefer to infect other files that can be detected. So, as I said, there is a delay with big compressed file. I had initially a problem with encrypted zip files. I put there being resolved, but now it's solved. If the proxy detects that the zip is encrypted and we don't have the password, it passes the data stream and don't infect it. The size, which is the final size of the zip file. We don't know that. Initially it was the file size plus infected data and some padding. Was the initial idea, the initial code I made is, okay, if the new malware I'm going to add is 1K, for example, I will increment in 30Ks the size, and then padding at the end of the file if finally the file is smaller. But finally I saw that you don't need to know the size. You don't need to put a content length on HTTP. That header that tells to the browser the size of the file you are downloading is not needed. It's not mandatory. It works. We are going to see the effects. Also, I added the capability of adding files on inside a zip. Now, to detect the proxy, to detect that you are downloading a zip file, it check the content type header and check that the content type is application zip, or if it's the generic application octet stream, it check the extension to .zip. Okay. Let's going to do the demonstration. Okay. The zip config here is the extension, or you can put the file name. For example, if the zip have setup.x, for example, infect that file, or can be by extension. For example, all .html files with a size less than 10K infect with this external command. If it's a CPP code, for example, if have this extension and the file is less than 10K, you can't open the file and change this string for this other string. This is another feature I added. You don't need here to change to use a external command. You can simply do a string change on text files. If a file is a .x file, less than 300 Ks, okay, infect it using this external program, for example. It's a text file, directly a string change. This is a test. We can add more modifications, etc. We also can add files to the zip. So inside the zip, create a directory called Leo and add a file with this name. This is the local path of the file we want to add. Okay, so we go to the proxy. Is modify zip. Okay. So here, without proxy, we download. It's too big. Okay, too be fast. Okay, no. A small one. Not all have zip files here. Here, for example, any zip. Yes, 552. Okay, it's a fast connection. Okay, save file. Yes. Okay. Now it's fast. Is the one without cache. No. This is the other one. Which was the version I clicked? 226. To download the same. Okay, finally downloaded. Completed. Okay. Now with proxy. Save file. Oh, exception. Not enough parent to modify. Okay. Here, oh, there is a lot of. Here we see in the log that there is a zip detected because it's using content type application zip. So it finds VLC 226 thanks txt. Okay. Oh, the text is in Spanish. I realize right now. Okay. Changing streams because we write that I configure that txt change HTML2. HTML, the things, the exe files, and inserting files. Okay, so I didn't check. I don't know which was the modified. I think it's this one. Yes. Oh, I didn't. Let me repeat. I didn't show you one thing. Now it's in the cache. Fuck. Okay, close. Open one again. It's just to show you what happens if you remove the content length. Okay, so third file. If you remove the content length, you're going to see that the file is downloading and the bar is moving, but it's not in the same way. You are not going to see the progress. Why? Because the browser don't know how much time it's going to take because he don't know initially the content length. But it still works. It still works. Okay. Now, if we go to the other downloads, right, there's only one. Okay, here. The zip, the first one I changed is this one, I think. The size is exactly the same. Let me check. This is modified. Okay, here we see the added file, an image. Okay. If I look for a text file, I don't know where is any skins, fonts. Oh, come on, need txt. No plugins, no messages. Oh. Okay. For example, here I said change here the A or OOO, for example. Okay, if we find, I know that there is, but I don't know where, an HTML. Yeah, I added an alert, said infected, and that things. So I don't know why this one is the infected one are smaller than this one. Oh, this is the infected. Okay. This is the infected one. And what the fuck? Why? I think I forgot and I download all the files through the proxy because I see all the VLCs infected. Okay. Okay, this one is not infected. Okay, this is the real one without the Leo directory, etc., and the other are the infected one. Don't know why. Okay. Now I'm going to explain OpenOffice XML. OpenOffice XML is basically Microsoft Office documents, docx, pptx, xlsx. So this is a standard, and it's basically a zip file. And the docx files, the Office files, are zip files with some zips inside there. The zips mostly are XML files, which represent the contents and the relationships of the file. You also can find image files or OLE objects. You directly can do unzip of a document file. So inside you are going to see that files. So, infect document file, Office files is similar to zip files. Okay, it's the same process to open the file, modify the XML files, add any file if you need it, and that is. For example, from an exploit, you can add an embedded RTF, all that things. How to detect that the target is downloading Office file. Okay, with the content type, again, if the content type is the generic, you have to check also the extension. And go directly to the demo. Okay, again. If you go to the config of Infect Office, you're going to see that it's a little bit simpler. The name of the file you want to modify, as it is text files directly. What I do is do a string change. So if you find this string, change to this other, and that things. For example, if you want to add something before the override tag, so it's change the initial override by this complete string, and then add the override, and the same with document, etc., etc. You have to study a little bit how to inject things inside the Office, inside the document. Also, for this example, we add two files, okay, to the document. One is an OLE object, and the other file is an image directly. So let's go to the proxy. Let's clean the log. And okay. Okay. I have directly here one document that you can download via close. Okay, let's close. Close here. An example of document that is get by HTTP. First, let's check. First, without proxy. This is fast, so it's a small document. Okay, save file. Download it. Now, first use the proxy. Now put the same file. Opa! The proxy is stop proxying. Launch. Something happened. Yes, something happened with the proxy. Download it. Okay, this is the original one, and this is the modified one. It's almost the double. Okay. Yes, I wrote Office, a document, and the modified one. We added here an object. Okay, if we are reading the edition, this object is very simple. It's an OLE object that can be done. The icon is going to change. It's an OLE object, okay? So for attacks, you have to be creative. If we change the name, okay, let's do it directly with the infected to zip. Yes, and you open it. you are going to see that it's a zip file, and inside the file there is now all the object and the media. There is an image is added. You can compare it with the original one, and that's how the proxy works. Okay, 4 minutes. So, other file types. It is to do. I planned to do the same with PDFs, with RAR files, with StarGC and APK files. I choose that extensions because I still see web page URLs on HTTP to download that kind of files. So if I see that, I see, okay, we can infect that and we can inject things there. I know how, but this is a one-man proof of concept. So if someone wants to help, you are welcome, because there is a lot of things to do. As I said, these extensions in project for a long future also to infect torrent files, macOS disk image, DMG or PKG. Also, it's very interesting to infect class files that exist inside jar files that are also zip files. So basically, the code to modify files inside a jar is already done. It's the same as the zip and Office documents. About the IDM, the program and to do is to port it to C. The program is made in Python. I want to port it to C to make it work on embedded devices, to do that on routers, and to add high-ability. Also, I want new techniques for infection on the fly. I were researching, and me and a friend, we were researching about avoiding the P signature check, and the result of that research is that last week we could infect one file, and that file is still signed without a certificate, without our own certificate. So for our next talk, it will be very interesting. Okay, the IDM is available on a JIT, and that's the end. If anyone have some question.
No questions from the floor? Well, all right. Thank you very much, Leonardo. Really appreciate you wrapping up the last talk in this track today.
Thank you.